Good day, guys. Today we are looking at partial differentiation in mathematics N6. So partial differentiation is doing more or less the same thing as differentiation. The only difference is that once you get the word partial, it means your main function depends on more than one variable. You can see this depends on x and on y. So when you are doing your differentiation, make sure you focus on the active variable or the main variable and only differentiate that. So we'll go through this exercise so that you can understand that better. So we want to differentiate z 2 times with respect to x. So we all know that we can't do a second derivative without first of all getting the first derivative. So we'll start with the first derivative of z with respect to x. So this is the way I'll handle it. The way differentiation works is that you go through that function, you only search for x to differentiate. If you don't see x, then what we are seeing is a constant, which we treat it as a constant. So if I look at the three terms, the first one has x, so I'm only searching for x to differentiate. If I differentiate x cubed, it gives me 3x squared. Then if I move to the second term, I've seen a 4, and I'm seeing a y squared, which are not x, but my target is the x. If I differentiate x squared, it gives me 2x. Then if I go to the last term, you see, there is no x. So my derivative, it means what I am seeing here is a constant. As long as it is not x, then the derivative of every constant should be a 0. But when you look at these other ones, you are not allowed to differentiate a constant when you are seeing the variable. You always prioritize the variable, differentiate it first. If you don't see the variable, then the derivative of the constant is 0. So this therefore means that the partial derivative of z with respect to x is a 6x squared minus 8xy squared. So for students who have understood how partial derivative works, they can just move from the problem and go straight to the answer without doing this first part I have done. But for the sake of making people understand, I will keep on doing it like that so that you capture the idea. So let's now go to the second derivative, partial derivative of z with respect to x. We are done with the first, so from the first, we can now go to the second. So to get the second derivative, we are now differentiating the first derivative. And don't forget, our main variable has not changed. It is still x. So I'm only searching for x to differentiate. So this constant, I'm not allowed to differentiate it when I'm seeing a variable. So when I differentiate x squared, it will give me 2x. Then when I move over there, I'm not allowed to differentiate it. I'm not allowed to differentiate y squared when I'm seeing the variable x. X is my target. So if I differentiate x, I get 1. So if I now multiply out my answer, I'll see that my second order partial derivative of z with respect to x gives me 12x minus 8y squared. So I've succeeded to differentiate the function z with respect to x only. So let's now repeat the whole procedure and differentiate z with respect to y. The same z. So this time our active variable is now y. So we'll follow the same procedure. If I look at the first term, there is no y. So if y does not exist, then anything you see there is treated as a constant, and we know in derivative that the derivative of a constant is a 0. Then if I move to the next, I'm seeing 4x squared y squared. So the 4x squared, I'm not allowed to differentiate it because they are being multiplied by an important item, which is your y. When you differentiate y squared, you get 2y. Then if I go here, differentiate, I look for the y and differentiate it, I get 3y squared. So this tells me that my first partial derivative of z with respect to y is negative 8. If you multiply it, you get negative 8x squared y plus 3y squared. I can now go on and look for the second derivative of z with respect to y. So that means I go through the first derivative, search for y. So in the first term, I've got negative 8x squared. They are not y, so I'm not allowed to differentiate them once I see my y. So I'll differentiate y to get 1. Then if I move to the next, I've got 3 multiplying an item that has y. If I differentiate y squared, it gives me 2y. So this therefore means that my second partial derivative of z with respect to y is negative 8x squared plus 6y. So you see I've differentiated the same function twice, but the first time with respect to x, the second with respect to y, and you can see the different answers. So let's now go to the last part, which says you are still differentiating z twice, but if you do it the first time with respect to x, the second must be with respect to y. So in this case, we are going to be a little bit faster because I want to differentiate it 2 times with respect to x and y. I've chosen to start with x. So if I'm starting with x, I can simply just copy the answer I did there. I've differentiated it with respect to x already, so I don't need to be repeating that. So that will give me 6x squared minus 8x y squared. So for my second derivative of z, since it's already done with respect to x, my target is now to differentiate my first derivative with respect to y. So I'm now looking for the derivative of the answer of my first derivative, but with respect to y. So that means I search for y only in my first derivative and differentiate it. So in the first term there is no y, so that is obviously a 0. Each time you don't see y, then what you are seeing is a constant, and the derivative of the constant is a 0. Then in the second, I see 8x, but I can't differentiate it because they are multiplied by the y I'm looking for. So if I differentiate y squared, it gives me 2y, and this will simplify as negative 16xy. So guys, that is the story of partial derivative with that very simple example. So let's now switch to another example that will bring us to some interesting ideas that we need to know about partial derivative. And that interesting idea is just for you to know that in partial derivative, the product rule, the chain rule, the quotient rules that we know in normal differentiation, they still apply. So with this function, we want to differentiate sine 2x multiplying cos 3xy with respect to x first, then with respect to y, and therefore we'll also do the second derivative. So if you look at just my first derivative, I've already arranged my problem to show you that it's a product. And in this product, because my target is to be differentiating with respect to x, it means I'll search through the product. If each function has an x, then I need the product rule. But if it doesn't have an x for both of them, I don't need the product rule. So this is a product that requires the product rule. So I must choose one item as u, the other one as v, and do my product rule the way product rule is done. So if I'm differentiating, I'll need u multiplied by v prime. So I've selected this as my u, which is sine 2x. Then I'll multiply by v prime means I differentiate this function with respect to x. So but to differentiate this is a function of a function. So I need the chain rule. If I differentiate cos, I get negative sine, which will still contain the 3xy. Then if I differentiate 3xy with respect to x, that will be telling me that I'll be differentiating only the x, because that's the active variable. So I'm not allowed to differentiate 3y because they are not x. So that will give me my 1 there. So you see, I've only done u, v prime. And I need to move to v, u prime. V means I capture the whole of cos 3xy, then I differentiate u. U is a function of a function. I differentiate with respect to x. If I differentiate sine, it gives me cos 2x. I differentiate 2x, it means I'm only differentiating x, which will give me 1. Then I multiply by 2. So that's how my derivative works. Then I can multiply right through. This will be 3y times negative. I'll get negative 3y sine 2x, then sine 3xy. Then if I multiply here, I get 2, which is plus 2 cos 3xy cos 2x. So I've succeeded to differentiate z with respect to x. So let's now look at the b part. We are differentiating the same z with respect to y. So let me bring down my z first. My z is sine 2x multiplying cos 3xy. So this time the variable has changed, and this is something you must be able to pick out. You can see the function looks like a product, but in terms of the active variable y, this is not a product, so we cannot apply the product rule there, because your y does not appear in the first function and in the second. So sine 2x is a simple constant. So I'm writing my sine 2x exactly the way it is. Then I'm only differentiating cos 3xy with respect to y. And to do this, I'm applying my product rule, my chain rule, where I will differentiate cos first to give me negative sine 3xy. Then I differentiate 3xy with respect to y. That means I will capture 3x the way it is. Then I differentiate y. I get a 1, which if I simplify, I will see that my derivative of z with respect to y is negative 3x. I have negative 3x sine 2x sine 3xy. So that is how it is. I can now go to the very last part, which requires us to differentiate y, z 2 times with respect to y. So to get the second derivative, we must finish with the first derivative. So I've captured my first derivative there, which is exactly what we are seeing down there. And again, if I want to differentiate this first derivative with respect to y, the story says go through your first derivative, only search for y and differentiate, which therefore means the first item here is a constant because it doesn't have y, but I'm not allowed to differentiate it because it is multiplying something that has y. So I'll capture this exactly the way I see it. Then I concentrate on differentiating only the term that contains y. And to differentiate this, we need the chain rule. So if you differentiate sine, give you cos 3xy. Then if you are differentiating 3xy with respect to y, it means you are not allowed to differentiate 3x. You only differentiate y to get 1. And if you simplify this, 3x and minus 3x will give you minus 9x squared, minus 3x times 3x is minus 9x squared. Then you multiply that by sine 2x, then by cos 3x y. So guys, that is the basics of partial differentiation. I hope I managed to take you through it. So all you need to know is that chain rule, product rule, and quotient rule still applies in partial differentiation. Thank you very much.